Okay. We're looking at trying to fix this function we've got called orthogonal match. Now, on page 4 of our debugging, we've got these values here called right match, left match, top match, bottom match. It's bottom match a nil. That's kind of weird. We'll have to check that out, make sure that's not a bigger problem, but it's not getting populated anymore on these. I don't know when that broke, but I left us a very nice note. To redo this. So I'm curious why the bottom match was getting nil. If we take a look at our occupant class, well, it's a nil because we're not even populating it. So that would help. But then it's still not working. So we just need to make sure when we do our placement in our play state here, like when do we run the orthogonal flush? We run it outside of our functions. Oh, we're not even doing it. We took it out. Okay, well, I'm looking for when we're doing our right here, yeah. Okay. Yeah, we stopped doing our, okay, that's why it's not working, is because we stopped doing it. I guess if we put so after we place a stone, right after we switch our players here, we do all of this stuff. So as long as that stuff is called in a determine horizontal win function, which I'm not sure it is, it should actually work now that we uncommented that. So if we take a look at our horizontal win function, we only do it upon a every column getting a white stone. So for now, we can just say forget whether or not it is all in the same line or not. And now let's see if it populates. Yes, it does. Okay. And we're no longer getting the nil bottom match white. And anytime we hover over, and notice how it's only the middle one getting populated right now. It's got a left and right in the middle. So we need to fix that. We see how we're only doing it right here on 3. We need to do it on all of our columns. So we would do something similar to this where we run it on every column. We could put it into the one function though, so that we don't have to call 5 lines of a function call. So maybe we'll do that. So if we take a look at our orthogonal match, oopsie, here we go. So yeah, instead of taking a column, we're actually not gonna ask for a parameter. We're not going to ask because we're actually going to be doing this for every column now. We used to only be doing it for the middle one, but now we're doing something different. So we're going to go ahead and populate every occupant with our surrounding values, our booleans of our surrounding matches orthogonally with every single, for every single grid, every single occupant in our grid. So, so at least we got it working again. And now all we have to do is update it so it does it not only for the parameter, but for every occupant. So let's see. We probably need to do nested for loop here. It's tricky. Okay. We have to do what we haven't done in a while, which is to do our corner exceptions. So it's like, basically we're trying to figure out if it's a corner piece, so a row 1 1 or a 1 5 or a 5 5 or a 1 5 1. If it's a corner piece, then we only want to check the corresponding orthogonals, because otherwise we're going to crash. And then we need to check if it's an edge, and then only do the sides and top and bottom, or God dang, yeah. Oh, it's annoying, but this is the last annoying thing. I feel like I'm gonna redo all of this. I feel like I'm gonna redo all of this because it's gonna be in a nested loop and we have to do the checks. So my initial idea is to just get rid of all this so we can start from a clean slate. So yeah, we've got to do a nested for loop. So we're going to do, not that, but okay. Okay. So we've got a nested for loop now to cycle through all our occupants. So we got to do a couple things. We got to do a corner case. Then we got to do all the edge cases. Then middle cases. So for our corner case, we're going to say if grid is, what do we want to do? We want to say if I is 1, J is 1, then we're going to be doing the top left corner case. We've got to do top right and then bottom left and bottom right. So we're just going to yank this. This will be our template. I guess we can put this in else ifs, right? Yeah, we could put this in else ifs. So how about we instead just go for coding in here like else if I is 1 first row, but our 5th column, that's our top right. Then do something, but we would say else if figure out how to go down the selections here. Okay, it's just Control N. Else if I is 5 and J is 1, then we do something else. And we'd say else if our I is 5 and J is 5. So that should cover all of our edge cases. We need an AND here. Okay, so that should be our corner cases. And we have to do this because if we're going to be asking what our surrounding stone control is, if we try to index above a top left grid, it's going to crash. So we've got to baby it like this. I don't know if that's a Lua specific thing or what, but we've got to kind of do that. So if it's I1, then we're going to run the specific... What is going on? What are you... Okay, so I think we want to ask at this grid, if grid at 1, 1 or IJ, whatever we call it, if grid at IJ dot stack control, no. Oh, yeah, we have to check for a stack control of white. Sounds like Sonic Pi is messing up right now. Sorry if that's been sounding gross for you guys. Let's say, go ahead and put I and J in here. And we'd say if that stack control is white and that grid's stone control, stone control is not equal to that of a standing stone, then we need to ask, once we get this in here, I, J, okay. Okay, whatever. I don't know why the tabs don't seem to be working okay, but so if we're a stack control of white and we have a stone control not equal to a standing stone, then we're going to go ahead and, you know what, this actually doesn't need to run through the very first column. So we don't have to actually do any corner case for our top left and our bottom left, because in our road start function, we're actually doing this sort of stuff. Is this our road start? Yeah, so see, we're doing a potential road here. Okay, so I think we can actually get away with not doing, since we're only going to be running our orthogonal match function on rows 2 through 5. Actually, 2 through 4. 2 will populate for 2, 3, 4. No, yeah, we have to run it on 5 as well. So we're running it on 2 through 5, so we actually don't have to do a left edge or a top left corner case or bottom left corner case. So that'll actually help us out a little bit. Okay. So we can actually start this at 2 and start this one at 2. And then we don't need to actually do the top. Let's see, we don't have to do column 1, which would be a J1. Or, yeah, so we don't have to do this one. Or J of 1, I of 5. Yeah, we don't have to do this one either. So we can just ask the two top right, row 1, column 5, and row 5, column 5. Cool. So we'll go ahead and say if the grid here at ij dot stack control is equal to white and grid ij stone control does not equal a standing stone, then we'd go ahead and check and we're only doing this for white so far, but yeah, if we're a stack control white and we're not a standing stone, actually, this is not what we want. This is busted. We can't just say these are 2, because we have to count for all the rows, all 5 rows in the middle columns, or from 2 to 5 columns actually. So we can't actually do that, but we can say if I is 1 and j is 5 still here. Yeah, and then it's okay. That should work. Now, if we've got stack control, see, this isn't. No, okay, this is right, okay. Because we're just worried about populating these side match booleans. And we'd only do that if it's a stone in our control. Because if we'd have to be able to check that it's in our control and where that grid is to be able to know whether or not to change the boolean. So if we're the top right, which this is the case with an I of 1 and j of 5, we only need to check our left side and our bottom side. So we would need to check our left side, which would be what? Our left side would be 1, row 1, comma 5. And then we would also do a one beneath us, which would be row 5, column 2. So we would be saying, okay, if we've got stack control in this top right corner, then if the grid next to us also has a stack control, that is equal to white, and that grid at 1, 5 stone control would have to not be equal to a standing stone, then we'd go ahead and change the boolean of our top right. We would say grid 1, 5 dot, and this is the one I want to put 1, 5 in here explicitly. So if our top right corner is occupied by a white stone control, not stone control, but white and not a standing stone, then we're checking. See, why is this? This isn't 1, 5. We need to check to the left of us. Left of us would be the 4th column. And then if the one to the left of us is a stack control, stone control, not equal to standing stone, then we would say, okay, our grid at the top right, it's right match white would actually be true. Oopsie. So we'd say right match white, it's true. And then we'd also ask if our one below us, same column but below us, if that has a stack control that is equal to white and a stone control, grid 2, 5 stone control, that is not equal to a standing stone. And then if that's the case, then we would say our grid at this 1, 5 would have a bottom match. Okay. That's the one case for a top right. So I guess at this point we can go to where we run this orthogonal match. And it looked like, okay, we passed in a parameter to our orthogonal match flush. No, we didn't, just to our orthogonal match. Okay, so we're trying to say we don't need that orthogonal match anymore with a parameter. And then we're gonna say, just make sure we don't run that again. Okay, we only run that in our horizontal win function. So now let's just see if our top right is working. We shouldn't have our middle one working anymore. Yeah, they're all still false, but I'm hoping if we have a white surrounded, we'd have a left and a bottom true, which Oh yeah, we need a left. Left match would get true, not a right match. Which is why we test things. So we can say, yeah, this would be a left match. Okay. Now we've got... Wait a second. Yeah, we don't need to care what our surrounding matches are. Well, shoot, now I'm thinking we do need to populate our first row. Because the function references the row before it, so we actually do need all 4 middle cases, all 4 corner cases, damn it. That's okay, I'll just do it. So we'll do if I is 1 and j is 1, our top left, then do something, else if if our I is 5 and our j is 1. Okay. Okay. The good news is we've got a sort of template here for our corner case logic, so we can kind of just copy this and adapt the right squares here. So for our top left, we're going to be checking our top left grid, and then we're also going to be checking our right and beneath us. So right of us would be same row, 1 more column, and then if that's true, then we're going to be changing our 1, 1. And then we need to check beneath us, which would be a 2 and a 1. So 2 and a 1. So now let's see if our top left corner case is working. When it's surrounded, we got a left match and a bottom match. We need to, opposite mistake we made last time, but yeah, we need to switch this to a right match. Other than that, though, I think it was actually working, so. We've got a right match and a bottom match. Cool. And we actually do need this first row because that's how we're determining whether or not to make this a potential road, is if it's directly connected. If any of our potential roads in road 1 has a right match, that right match automatically gets set to a potential road. That's the first step of that part. Then we have to change the vertical matches to also become a potential road, but we're not there just yet. We're trying to get these orthogonal match booleans working right without crashing, and then we can move on to the juicy stuff. So I'm going to do this again where we say I5 and j is 1 would be our 5th row, bottom, our first column, so our bottom left. So we would say I5, 1, and then our row of 5, place 5, come on. And then our bottom left needs to check above us and to the right of us. So we could do the right of us and then our, is it top, bottom, top match? Is it top match? Yeah, top match. So bottom left, we're going to be modifying the 1, 2 above us, which would be 1 less on the row, same column. So this would be 4, 1. This is above us. Oh, let's do the right of us here. This would be same row to the right of us, which would be 2. Okay. And then above us would be 4, 1. So we would just say 4. Okay, let's check our bottom left. We do not populate any of them, so what's going on? I is 5, J is 1. 5 being the 5th row, J, okay. We've got white, stack control. Then if the 1 to the right of us. Okay. I don't know what's wrong. I don't know what's wrong. Oh. Well, it seems to be working now. I don't know if I was just being dumb. Left match, bottom match, okay. Right match, bottom match, okay. Right match, top match. No, right match and bottom match. Okay, we mess that up every single time. How was that a bottom match true though? Actually, that's kind of confusing. We actually have it right here, top match. See, that's, why is it false here? Now, we must be messing something up. None of those values are written anymore. Oh, until it got to here. We need to take out the else ifs. We need to take out the else ifs. It's just not working as intended. So we'll just give everyone their own if statement. And then now let's see. Okay. Yep, now it's working right. And just to make sure. Only a bottom match, okay. Only a bottom match, okay. Top match, yes. And right match, yes. Okay. So we've got all but the last corner. Let's see if we can get it right in the first try. So we're gonna take this and we're gonna put it. We're gonna be bottom right, so this needs to be 5, 5, and then now the ones we're trying to do in the bottom right is above us and to the left of us. So above us is fine, but to the left of us needs to get updated, and we only do that if the one to the left of us is a stack control of white and stone control not equal to standing stone. So left of us from our 5, 5 grid would be 5, 4. And then above us would be 4, 5. So we would say 4, 5. Okay. Let's see if our bottom right is working. Just a left match. Let's check that our top match is in fact working. Not what I wanted. 4. Left match, top match. Okay. We've got our things working. Let's test a standing stone and make sure that is not messing anything up, and actually we want to do a capstone and a standing stone. So we've only got a top match because our capstone counts, but no left match because our standing stone does not count. So that's looking like it's working. Okay, so we've got our corner cases done for this function. Let's do our edge cases. So we know it's an edge case. If we start with if our I is equal to 1. Why not? Why don't we start at our top? If we're on our first row and our J does not equal a 1 and J does not equal a 5, then this would be the top case. Which means we would be checking left, bottom, and right. We'll leave each one of the edge cases in their own if statement. So let's do our right side now, which would be if our J is 5 and our I is the one not equal to 1 and our I is also not equal to 5, then we'd go ahead, test that. Our bottom would be if our I is 5 and our J is not, is not equal to 1 and J is not equal to 5, then we would do this, and then our left side, which is if our J is equal to 1 and our I is not equal to 1 and our I is not equal to 5. That would be our okay. So J5 would be right edge. Fifth row, yep, right edge. Which means we'd have to check above us, or top stone, top check, left check, bottom check. And then I5 is our bottom edge. So we would say that we need to check our left, our top, and our right. And then J is 1, that's our left edge. And we would say left edge. We need to check above us, to the right of us, and beneath us. Yeah, we have to do these shenanigans because if we accidentally ask for the stone type of an occupant that is off the grid, it would crash the game. So we have to kind of baby it and put these guardrails on. So, yeah. Okay. I guess this would mean that we would be asking, okay, if our grid is 1 and our J is whatever J is, we can just keep this at I to ease up confusion. We'd say if this one's stack control is equal to white. Come on. And this grid at our IJ stone control would be equal to, actually not equal to, standing stone. So basically this is just saying don't even change the top match stuff if we're not in fact a white stone that isn't a standing stone to be matched with. So we're first ensuring that we're a white match to compare to, then we're going to compare to our left, beneath, and to the right, because this is our top check, our top edge case. And then our middle cases are going to be somewhat easier, because all we do is say, you know, if I is greater than 1 and less than 5, and J is greater than 1 and less than 5, go ahead and check every surrounding grid, populate if it's a match. So okay. Yep, we need to check left, bottom, and to the right. So I'm just gonna put the values here like ing.stack control and stone control. Okay, so we need 3 lines of this. And the first line is our left, which would be a row minus 1. So we'll go our second row is bottom. So we would say I plus 1. So if we go here, we go and plus 1, that should be beneath us. And then we need to check to the right of us, which would be column plus 1. Now notice how we actually can't crash here, in the sense that what if we're on row 5 and we try to index a 5 plus 1 grid, which we don't have anything past a 5? Well, this is ensuring this J is not a 5, because it's an edge case. So it wouldn't be an edge case if J was 5. So that's actually covering our butts there. And then I guess it would be where we'd go to the beginning and we would say, if that stack control to the left of us just now the thing we're trying to modify is actually the same occupant, just different fields. So this one is to the left of us. So we would be saying, we'd be modifying grid at IJ. And the field of a left match white. Now we would be saying this one is beneath us, so we can say that beneath us, so bottom match. And then this would be beneath us. No, to the right of us. Right match. So now we should have top edge working. We've got a right match and a left match. And we've got just a right match. Okay, top edge seems to be working. We've got a bottom match and a left match. Cool. Seems to be working. So we've got our top edge case. Now we can move on to our right edge. So this would be very similar. We say if our current grid is in fact a potential, actually a road to be potentially connected with, then we're going to go ahead and ask about our surrounding locations and their stack control, first of all, and I still hear Sonic Pi freaking out, so sorry if that sounds atrocious. Now here, we need to do 3 things, and we're going to be asking about the 3 different controls. I'm going to give us a little template here because we know we need something similar for the others. So I'm going to say our grid ij dot stack control is equal to white. This will be our directions, and our grid down control. Not what I wanted. Really bad at this. We need 3 of these, and each of them needs to be the direction. So this will be our little template. So we'll go ahead and okay. The thing we're trying to modify is the grid's original whatever thing match white is. So we'd have to put in the direction there, but we could in fact this is our little template. I don't know what's going on. Like I lose the buffer of my clipboard. Oh, you know what? It's because I delete. Anytime I delete something, it overwrites the put buffer. Just like that. When I delete a line like that, it overwrites what I've got copied, so that's probably why. So yeah, okay. Now we just need to give the right values. So This one's correct. Then we need our top, so one above us. One above us would be a row minus 1. So row minus 1 would be above us. That's correct. And then, actually this is wrong, shit. If we've got stack control on the right edge, then we're gonna ask above us. This is fucked up, this is wrong. Messed up our template. Okay, easy enough though. I think it's just we need to take out one of these. And then we just do above us, which would be, this would be a minus 1. And this would be a minus 1, and that would mean our top match would get true. Then we're asking if the one to the left of us, so that would be a J minus 1, and then that would be a left match. And then the below us, which would be an I plus 1. And then that would be a bottom. And then this is a bottom edge. So we're asking for the left of us, which would be our row minus 1. No, a column minus 1. And then that would be a left match. And then we're checking the one above us, which would be a row minus 1. 1. That would be a top match. And then to the right of us, which would be a column plus 1. Okay. Then this is our left edge. Which means we're checking above us, which would be a row minus 1. That is for the top match. And then right match, which would be our column plus 1. And column plus 1 for a right match. and then to the bottom of us, which would be an I plus 1. And that would be a bottom edge. Okay. So let's see if our edge cases seem to be working. So we'll just put a bunch of stones on our edge and see what may be working. We've got a left match only here. Okay, so this one should be a right match. Right match. This one should be no match. Correct. No match. Correct. Right match. Correct. Left match. Correct. Top match. Correct. Bottom match. Correct. Okay, I think we've got our edge cases sorted. So now we just need our middle cases. So this will be fairly easy, I think. We just have to say if I is greater than 1 and I is smaller than 5, and j is greater than 1 and j is smaller than 5, then we've got a middle case. And what we need to do in that case is search every orthogonal spot. So we would say, let's take so if our grid here is in fact a stone control, then we're going to go ask every case. So this should be really easy. We just did to do all the cases. So we need to see if this would be, let's start with our top. So we would say if the one above us, which would be an I minus 1, the one above us, minus 1, if the one above us is a match, then we would say the grid at our current location, Boolean of top match white would get true. And then we need to do the others. And we would say, I guess we can say, we go to the right of us, which would be aj plus 1. And that would be the one to the right of us. Then we'd be a right match. And then we need a bottom match. So bottom would be same j, but an I plus 1. And then a left match would be j minus 1, which we can actually do like this, replace with a minus. We could go find plus, and then replace with a minus. So now we should have all the middle cases done. So let's see. We've got a right match, which is right. We've got a right match, which is right. We should have a top and a left match. Left and top. We should have just a left, just a left. We should have just a right and a bottom. Right and a bottom. We should have just a left. Okay. We should have none. Yes. Right and left. Right and left. Okay. I think we did it. So now, actually what this allows us to do, now that we've got that, now we can actually do our potential road function. Because now what we're going to do is say, we've got our road start function. That's why this is blue. But we would need this one to become blue if it's connected. And how we're doing that is going to be, we run our potential road function, passing it in column 2. And what it's going to do is say, okay, you pass it in column 2. I'm going to go take a look at all the potential roads of the previous column. So column 1. It's going to cycle through all those potential roads and check for a direct orthogonal match and change it to true. And it's going to go through every single potential road in our left column, and if the one to the right of it is a potential match, which it doesn't have a right match, but this one does, that means that this grid would become a potential road. And then we need to add the second step to that function, which is to change any vertical orthogonal spaces to that grid to be equal to a potential road as well. And then we can run that function on every single column, and hopefully that'll actually build out our entire algorithm for a horizontal wind detect. Then we need to kind of invert it and do the vertical detect with slightly different arithmetic, but we don't have to incorporate the surrounding stones. Well, we have to add it for black, obviously, but we've already got our booleans of our matches being changed correctly. So all we'd have to do is go through, make sure we do it for black as well. So we're getting there. We started the day with a totally jacked orthogonal match function that I left me a note that says, redo this, please. And we finished with a actual working orthogonal match that works on not just the center column, but all the columns, and it doesn't crash. So we've got the framework to start our potential road function now, and it will be a lot easier now that we've got these booleans in check. And we should, I'm going to double check that those booleans actually get updated if they get overwritten by another stone, which they should, because I do the match flush before every single time we call that populate function. So anytime we do that orthogonal match, we're flushing it beforehand. So right now we've got all trues on the matches, which is true. But if we were to cover up, say that side, and cover up, say this side, then now we are false on the left and right match because we don't have stone control anymore there. But if we were to, example, take control back, now our left match is false, but our right match is true. So I think it's working. And then all we have to do is extend our potential road from this first column only to, once we write this potential road function that takes in a column, once that's working for one, we just say, boom, run it on column 2, column 3, column 4, and column 5. And then it'll generate any potential road. And if there's any potential road in column 5, we know that is a win. So we are almost there. I'm getting excited because we're so close. And then we get to do the fun stuff, and we can't do the fun stuff for a little while. We got to do all the resizing stuff, make sure it works in full screen. But yeah, then we can worry about making it look pretty. Let's take a look at our get diff. We fixed a bug where we weren't actually having a bottom match field. And then, actually, I don't like doing the get diff in Vim because it shows our comments as dark blue. So if we exit this, we exit Vim, then we run a get diff here. Now we've got the bright green changes that we added. We took out our old orthogonal match functionality. We added in our correct orthogonal match. Look at all of these white spaces I've got in there. I've got all these white spaces I need to delete. And then, yeah, we stopped our orthogonal match from being column dependent. We actually turned on our horizontal win to populate those match booleans. We've got a bunch of these white spaces I want to get rid of, but I don't know if I'm going to exactly do that or not right now. It's hard because I can't see those. I can't see those. Oh, I just saw one right there. So I guess if we're at the end and we just go down, we can see if there's any white spaces like that. There's a plugin for Vim that will do this. That'll highlight the white spaces you may have put in there. So I would like to get that installed at some point, because I don't like those hiding in there. Yeah, it'd be handy to have that function there that would highlight those white spaces so I don't have to search like this. Okay. Okay. Let's write that out. Let's quit. Let's go ahead and get diff. Let's see if we got rid of those white spaces. We've got one there on the corner case. We really have them there? I swear I took them out. I don't get it. That was one. Hiding. That's one hiding. That's one hiding. I really need to get... Oh! I really need to get that plug in because this is just silly. I don't think it'll crash us, but I don't want that to happen. There's probably a whole bunch more already, actually, that I've missed. Okay. Now let's see. We still got a couple ends. Damn it, man. So right before middle cases we got some. Right after edge cases we got some. Yeah, I really need to get that installed so I don't have to spend my time doing this. I got one right there. You know what? I don't care. I don't care. I'm gonna get that plugin that shows empty white spaces and then I'll delete them later. This is fine though. So if we git add a commit saying this is our fixed orthogonal match function to update match bools appropriately. Come on, dude. I do have correct access rights. Oh my god. Is GitHub down right now? It is down. Do I not have Wi-Fi? Don't have Wi-Fi. Okay. So we should be able to do that now. Cool. All right. So tomorrow we'll continue where we left off, and we'll actually work on our potential road function. We've got our first column with our road start function, but now we need to use these booleans we just populated today, and we're going to be able to figure out how to determine a road horizontally with our new function tomorrow that we flesh out. I'm thinking it won't be that difficult. The hardest part is going to be the second part of the function, which is to also make a potential road on any vertical connects. So that's the trickiest part. But I'm not too worried about it. I think we'll be able to do it. It won't be that pretty necessarily, but I'm feeling pretty confident about it. So I'll catch you tomorrow.